The real numbers is an example of a mathematical idea called a field. Fields have to have these certain properties. The first of the properties that are accommodating fields is closure. Closure guarantees to us that if we're doing the operation, that the answer will still be part of the same set. So if we have A and B are real numbers, then so is A plus B. Also, for multiplication in this case, A times B is also guaranteed to be a real number. So the operations of addition and multiplication are closed in the real numbers. Whenever you do these operations, you'll definitely get that same kind of number back again. Now remember, real numbers, you could add these together and get an integer or a rational, and they're still considered to be real numbers. Next, we have a property you've probably heard of, the commutative property. Now, the commutative property, commute, means to go back and forth. It assures us that if we add A plus B or B plus A, we can add in either order. So the commutative property says to us that we can change order without worrying about things. In multiplication, it's AB equals BA. A third property which fields have, and the real numbers share with other fields, is the associative property. Associative property has as its root associate, which means to gather together. So the associative property's key thought is grouping. And we have that A plus B plus C grouped in this way can be equal to A plus B plus C grouped this way. The order does not change when you're using only the associative property. Only the way that the items are grouped is changed. Also for multiplication, we can group AB together and then multiply by C, or we can group BC together and multiply by A. In either instance, this property assures us that we're going to get the same thing. We'll do one more property here before we convert over to another page. That's the existence of identity elements. Now, there must be an identity element for both addition and multiplication. An identity is an element that when the operation is performed, nothing happens. So what do we add to something so that it doesn't change? 0. So if we have A plus 0 equals A, we know that 0 is the additive identity. Multiplication. If we multiply A times 1, we still get A. Since 1 is the number that when multiplied by any other number, you just get that number back, essentially nothing happens, then we know that 1 is the multiplicative identity. So the real numbers have an adding and a multiplying identity. 0 for adding, 1 for multiplying. The associative property, commutative property, and closure. We'll look at several more properties of the real numbers and inequalities in a minute. The fifth property of fields is the existence of inverses. There are additive inverses for every number and multiplicative inverses for every number. First, let's consider additive. You have an inverse of another number if, when you perform the operation, you get the identity. So we're saying that if we take A and add something to it, we should get the additive identity, which is 0. What should that number be? It should be the opposite of A. So the additive inverses of numbers in the real number system are opposites. We also have multiplicative identities. The multiplicative identity is 1, so what are the multiplicative inverses? We need to multiply A times something to give us the multiplicative identity of 1. What would that be? Well, how about 1 over A, or the reciprocals? So if you're looking for a multiplicative inverse, you're really looking for reciprocals. If you're looking for an additive inverse, you're really looking for opposites. There we have the main properties with one more to add to the list. One you've used a lot, no doubt, in your past math courses, the distributive property. The distributive property is the only one that uses both adding and multiplying in it, and it looks like this. A times B plus C is equal to, and the distributive property sort of deals out the values, so A gets distributed to B and C, so we have AB plus AC. Notice the distributive property starts with parentheses, but on the other side the parentheses are gone. It can be used in both directions, and we'll use that property a lot.